All right, there we go. Okay. Remember what we did yesterday? We did that thing with my, for those of you that were here, we did that thing with the thing.
Yeah.
And the other thing?
Yeah.
What was it? It was called the third difference. I called it that. And we basically showed you that, yes, indeed. Why aren't you opening? There. Why aren't you opening? Can you believe this? All right, so we'll open, we'll preview. There you go. So we were able to show, yes,
I got my math binder yesterday and I had all my stuff in a different folder. Can I go grab my packet?
you need the packet? Please, I don't have any other copies, so we'll have to go with that. Thank you for letting me know at the beginning instead of at the end. So we basically learned about first differences, second differences, third differences. In a linear equation, what's the highest exponent that I have after the x? Who remembers that? Linear equation means my highest exponent is what number, Trey? 1. Very good. Very good. And quadratic, what was my highest exponent? Mason? 2. And then in a cubic, Danica? 3. There you go. Because counting, right? Similarly, first difference in a linear equation with the exponent being 1, first difference was always constant. In a quadratic, with my highest exponent being 2, the second difference was always constant. And in a cubic, with the highest exponent being 3, my third difference was always constant. And we used this spreadsheet to show how third difference is always constant in a cubic. Okay? So now what I want to do is I want to go back to the lesson that we handed out to everybody. And this is the lesson with Mr. Erickson's chicken scratch all over it. So what I'm going to do is I am going to clear ink from page. And we're going to talk about the opening exercise, but we're only going to skip around that because we did this yesterday, right? We talked about patterns in these lists of numbers. Real quick though, what's the common difference? Is there a common difference between these numbers? Is there a consistent difference between this number, this number, this number, this number, this number? Yeah, what is it, Bailey? 1. From here to here, I jump 1. From here to here, I jump 2. From here to here, I jump 3. Well, no, I'm sorry. From here to here, I jump 1. Here to here, I jump 1. Here to here, I jump 1. So forth. This one right here. From here to here, I jump how many? 6, 5.8. 5.8. You see how I did that? No, it doesn't matter. 11.56 minus 5.76. Who's got their calculator? Not their cell phone. Not the cell phone. You weren't here for that speech, were you, Ethan?
No.
All right. So, calculator. We lose to Prescott. We can't lose to Prescott, can we?
No, that was way better than the first
That was way better than the first one. Okay. But, so what's 11.56 minus 5.76? Is it 5.8? I'm going. I am faster than a calculator.
5.8.
Yeah, there we go. All right, 11.56 to 19.36. That's 7.8. Yes? 7.8. Here to here. That is 9.8. 11.8. Okay. So we got 5.8, 7.8, 9.8, and 11.8. Now, that's the first difference, right? What's the second difference?
2.
So 2, yeah. Second difference?
2.
Second difference?
2.
Common second difference. So we know what about this? What type of function, what type of equation does this list of numbers represent? Linear
No.
with the exponent 1?
No.
Quadratic exponent 2?
Yeah.
Yes, yes. Now, 5.8 to 7.8. What's the difference? 2? 7.8 to 9.8? 9.8 to 11.8? So common difference is the same. It's all the same amongst all of them. So we know that is a linear equation, right? Long way to go to talk about that. Now, I want to skip the rest of that garbage. Okay? Because now I'm going to clear ink from page again. And I want you to start thinking abstractly here. Okay? I want you to start thinking abstractly. It's telling you it's asking you, what is the sequence of first differences for the linear polynomial given by ax plus b, where a and b are constant coefficients? Okay, what does it mean to be constant? Kaya, what does it mean for a coefficient to be constant? If my temperament is constant, stays the same, right? Now, my temperament is not constant. I'm all over the place, right? But more like Schultz, right? Schultz has a constant temperament, am I right? What do you think, Mason? Is Schultz pretty constant in his temperament?
Yeah.
Whereas I'm like, Schultz is steady, okay? Think Schultz when you think constant, right? Always the same. Now, how do we do this? How do we find the sequence of first differences? Again, I want you to think abstractly here. What do I mean by that? Well, let's think about x is my variable, right? And let's set this to y. So y equals ax plus b. And I'm going to chart x compared to y. Let's start that. Let's start with 0. And go 1, 2, 3, 4, and 5. Okay? Now, when I do that, when I plug 0 in for x, what is my y? What's a times 0? 0. And then I add b, so y equals what? B. Okay? So when x is 0, y equals b. Now, when I plug 1 into this equation for x, what do I get? What do I get, Abby? I get a here, but don't forget we're also adding b, so I get a plus b. Do you see that? Hi, it's Giselle, right?
Yeah.
I'm getting these names. You can watch this on YouTube tonight, Giselle. I made a really unfortunate reference that I had to issue a YouTube apology for. So everybody witnessed it here except for Giselle, right? But it's okay. I made my apology. Anyhow, a plus b, right? Right, Michaela? Okay. When x equals 2, what does y equal? I plug 2 in for x, so then I have a times 2 plus b. But I don't like saying a times 2. How would I say that, Mason?
2a plus b.
2a plus b. I basically just flip them around, right? Because I like to have my coefficients in front of my variables, right? So 2a plus b. Hunter, if x is 3, what would be my y value? So I put 3 in for x. So it's a times 3 plus b. How would I write that down here?
3a plus b.
Very good. 3a plus b. 3a plus b. 4a plus b. Right, Ty? How you doing, Ty?
Good.
You're going to see a video here. You'll be able to see it on YouTube. All right, everybody together in unison. Don't worry, we didn't make any jokes at your expense. Yeah. No, we didn't. I promise. I promise you. All right, and the next one, 5a plus b, right? All right, so now I say think abstractly here, right? I got numbers here, but I got a lot of other stuff, right? I don't know what that other stuff represents, but I know what about A and B. They are what? Constant. They're Schultzes, right? They're Schultzes. Okay. So now what we're going to do is we're going to do a first difference because it's asking for a sequence of first differences, right? So let's do that. We're going to do that between this and this. So if I take A plus B and then I subtract the previous term from it, that's the B, right? So the previous term from this is B. So A plus B minus B. What am I left with, Michaela? I'm left with A. Good. A. Leah, if I take 2A plus B and I subtract A plus B, what am I left with? I'm sorry? Let's do the work here. So I got 2A plus B, that's here, right? Minus A plus B. Why did I put the A plus B in parentheses? Why not just write it like this? Well, am I subtracting A plus B here? I'm just subtracting A here, right? Here, I'm subtracting the whole thing in parentheses. That's why I put parentheses around it. Okay? So, distributive property. Anyhow, when I do that, I gotta distribute the negative. So then I got 2A minus A, which gives me what? I'm combining terms right now, right? I got 2 A's, I take 1 away. So how many A's do I have left? 1 A. And then I got 1 B, and I take away 1. How many B's am I left with? 0. So it's A. Okay, now we're going to do 3A plus B minus 2A plus B. What do you think my difference is going to be? Somebody other than Mason.
1A.
Yes, but what's your name? Jasmine, thank you. A. I got 4A plus B minus 3A plus B. I got 4 A's minus 3 A's gives me 1 A, right? And then I got 1 B minus 1 B leaves me with 0 B. So I'm left with A again. And then lastly, 4A or 5 A's minus 4 A's leaves me with how many A's, Jordan? 1 A. How many B's? No B's. So that is going to be A again. Common first differences, right? Linear equation, that's what we expect. What are the second differences for that? If I erase this right here, which I'm going to right now, let's erase that. Pow. And I do second differences. What is my second difference between that and that? A minus A.
0.
0. Very good, Bailey. A minus A.
0.
0. 0. You see how second differences in a linear equation really don't care about them, right? Because they're always 0. Third difference is going to be 0. Fourth differences, 0. Fifth differences, we really don't care about them. We just care to where we get to the same difference all the way down. Okay? Now, Here's what I want us to do. Let's find the first difference, the second difference, and the third difference of this polynomial. So what kind of polynomial is this? Quadratic, right? It's a squared. The highest exponent is a 2, so it's squared. That means quadratic, okay? So when x equals 0, x is 0, right? 0 squared is 0 times a is 0. X times b, when x is 0, 0 times b is 0. I'm just left with this c, right? Yes, and they got that for you here, right? When x is 1, they got it, right? X 1 squared is 1 times a is a. When x is 1 times b, I get b and then c. Same thing here, 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 and here. So all we have to do is subtraction. So first difference. What's the first difference? Sydney, what is the first difference for those two equations? I got a plus b plus c, and then I take away c. A, not ab, that's a plus b, right? AB means a times b, vastly different than just a plus b. So good, good. A plus b. Do we see what's expected of us? Let's take about 5 minutes and fill in as much of this as we can. Work on your own, work with a partner or in a small group. I am cool with any of it, except I need some water.
We're just doing the first differences.
You got the first ones done? Nice. Let's see. 3 and 1. Good, good. Good, good, good. Okay, now work the second column. So now it's this minus that, right? Work with us. Do you have this sheet with you? Do you have that packet?
Yeah.
Bust it out and work with us. Then when you watch it later on, you can take advantage of the Department of Redundancy department. You know what that is, right?
No.
So we do things twice. Engineers use redundancy all the time. You just do things twice. So if one thing fails, the bridge don't collapse, and right? Yes. You don't have a packet. Yeah, I was hoping that wouldn't happen. I have to print one, okay? I have to print one. So give me a hot second, and I shall print one. Oh! That is bad. Beware of flying. What the heck happened? It's not funny, guys. It is not funny.
Sounded destructive.
It is not funny. I don't care what you say. That is not funny. All right. No, there. Oh, here we go.
Where's Gilead? Legion? He's bringing spaghetti. I'm pretty sure.
Does anybody else need this? I got it up right now. Does anybody else need it? All right, Giselle, it's coming out on the black lab. Go ahead and grab it, and I will pop a staple in there if you need it. Yes, sir. Yeah, you may. How's that? We'll get that out.
Yep. Putting our minds together. Why is my writing gotta be so bad?
What about the other one?
Can't even read it.
You just did what I did. Man, and then you're asked to use the bathroom. You can give me that column at least, and then you can go to the bathroom. How's that? Give me something. Because tell you what, if they say, "What did Hunter learn today?" I'll be like, How we doing?
What did Trey Freeze learn today?
Whoa.
Got 4 A's here. How many are you subtracting? And then how many B's you got? Yeah.
Whoa!
Check this out.
What?
Is it locked?
I do. Where did on the thing? I got 2. You know what the room key looks like? Give me a second, Jared, because I saw something. Thank you. All right.
First line.
All right. How we doing?
Great.
How many people were able to get the first column filled out? All right. Let's lay it on me. What do we got for the second entry in the first difference column?
3A plus B.
3A plus B. Who agrees with that? I buy that for $1. 3A plus B. All right. Here, what is our common difference? Or not the common difference, the first difference. What do we got here? 5A plus B? I heard it.
7A plus B.
Nice.
9A plus B.
And 9A plus B. All right. Next column. Who was able to get the second column filled in? All right. Michaela, what is your first entry in the second difference column? 2A. 2A. How'd you get that? Well, 3A minus, I'm taking away 1A, right? That leaves me with 2 of them. I got 1B here, taking away 1B. How many B's am I left with? 0. So 2A is my second difference there. What's my second difference here, Jared? 2A. 2A. Second difference here. We see a pattern here, right? And we should know this, right? Because quadratics have what? Which difference is constant? Second difference. Order 2, exponent 2 means the second difference should be constant. So this is going to be 2A. This is going to be 2A. And then my third difference, well, it's really trivial, right? 2A minus 2A is 0. 2A minus 2A is 0. 2A minus 2A is not 2. 0. There. Okay, good. Now, next page. Clear ink from page. Oh, no, I didn't want that. I want a clear ink from page. There, much better. Okay, let's do the same thing, but this time with the cubic. Shall we? Cubic. So you got, not only did they do the equation or the expression, they also did the first difference. So now we start with finding the second difference. So A plus B plus C is being subtracted from this hot mess. 7A plus 3B plus C. What do I get? Go ahead, Jordan.
6A plus 2B.
6A plus 2B. So I had 7 of them. I took away 1. I get 6. I had 3 of them. Took away 1 of them. I get 2. I had 1 of them. Took away 1 of them. I got nothing. All right. So now do the rest of the second difference. And if you got time, get a crack-a-lackin' on the third difference.
Wait, no, that one is.
How you doing?
Good.
Doing well. What's your name again? Anthony. Okay. What you got?
I'm starting to understand it all.
Okay, good. Okay. And that's gonna happen. Sometimes I'm gonna do better at something, sometimes he's gonna do better at something. So, okay. Okay. Well, the big thing I want you to figure out right now is, remember what we said here is, we said that if you go back, where is my, you got that done?
Yeah.
Nice, go. Thank you. So we got 5.76, and we got 11.56, and we got 19.36, and we got 29.16, 40.96. And we said this was 5.8, 7.8, 9.8, 11.8. That's the difference there, difference there, difference there, difference there, right? That's the first difference. So this is the first difference, right? Now the second difference is 2. Second difference is 2. Second difference here is 2. And because these two are all constant, what do I know about this list of numbers? It's represented by a square function, right? Or what we call quadratic. So when he's talking about square, that's why you put square there, is because the second difference is constant. Did you feel me?
Yeah.
I don't know what you, but I got number 4.
This helps you. Well, the difference is, so when I say first difference,
Difference from that.
so you got a list of numbers here, right? And this is the difference between this and this. This and this, right? So that's what I was talking about. And if you look at this, this is really, these are all related. So
Flock of bats.
the big thing I want you to get at is that the differences are, if I look at the first difference and then the second differences are all the same, and I know that's a square function, right? Feel me?
Yeah.
Okay.
Square function.
Yeah.
So then, that's square.
Yes. This is square function. Yep, because the second differences are all the same. Exactly. Now we're in the cubic, and we're going to get down here. We're going to get over to here.
Oh yeah. Oh yeah.
Well, minus 2.
I got 400K.
Plus, because 5 minus 3 is positive 2. You got it from here? All right, thanks, Anthony. All right, who was able to get to filling out the second difference column? Word. All right, what do we got for the next second difference? Cam, what do you got right here? The second entry. 12A plus how many B's? 2B. 12A plus 2B. I got 19 minus 7 gets me 12. 5 minus 3 gets me 2. Cool in the gang. I gotcha. Okay. Next second difference. John, I haven't called on you. What have you there?
18A plus 2B.
18A. 37 minus 19. Yeah, 18A. Minus 7 minus 5 plus 2B. All right. Lastly, Giselle, were you able to finish this column? I'm catching you off guard because you came in late, but I'm hoping you can. I got 61 A's right here, right? I came from 37 A's. How many A's did I go up? 61 minus 37, right? So that's a bit. I can't do that in my head either. Why am I asking you that? I can't do that in my head either. 61 minus 37. So 24. 24. Is that right?
Yeah.
All right. 24A. But you had 9 B's and you took away 7. How many B's you got left? 2. There you go. plus 2b. Okay, and then you had 1c here, you had 1c back here. So how many c's did you go up? 0 c's. So we just leave that off. Good. Now, so that's second differences. Third differences. Boom, boom. Who got this column filled out? Michaela, what's your first entry? 6a. 12a minus 6a gets me 6a. 2b minus 2b, there's nothing left, so 6a. How about the second entry in that column? Leah, 6a. 6a. I think I see a pattern here. Blue sweatshirt. 6a, you are absolutely right. I want to give you credit by referring to you by name. Briley? Briley.
Riley.
Ah, Riley. Okay, got it. 6a. Okay. Oh, look. Constant third difference. Huh. Huh. Now, I say to you, I want you to think abstractly. What's the benefit of thinking abstractly? Do I care what a is? This is what we call a universal truth. This is called a universal truth. So, if that number is 4, then my third difference is always going to be what? If a is 4 in this polynomial, so it's 4x cubed plus something x squared plus something x plus 2, what is my third difference always going to be, Leah? Not 4, but 6 times 4. So 24, right? My third difference is always going to be 6 times whatever this coefficient is. Okay? Similarly, on the last page, in a quadratic, whatever this coefficient is, right? My second difference is always going to be 2 times that. So if this first coefficient is a 12, what's my second difference going to be? What do you think, Rose? You were looking at Sparty here, weren't you? Yeah. Am I right? Is that what you were looking at? Okay. How great is that? That's like geometry right there. I was like, anyhow. So, if my a value up here is 12, what is my second difference going to be? Well, if it's a up here, right, my second difference is 2 times a, right? So if a is 12, then what is my second difference going to be? 2a. And what is a? A is 12, right? In my example. So 2 times that is 24, right? So my second difference is going to be always 2 times this variable. This is important because you're going to find out in calculus why this is. Actually, at the end of pre-calculus, you'll find out why this is. So, we've done that. Now, we're going to use numbers. Fill in the table, ladies and gentlemen. How much time do we got? We got 15 minutes. We got 15 minutes. Fill in the table.
Yeah. 5. -1. 5.
It's 5.
It's 5. It's 5, right?
Yeah.
Barely. I was like, what?
What? This one? Bailey.
What's that?
6.
It's not 6.
Yes, it is. It goes up by 6.
Oh.
You know, Mom doesn't remember. You know, there's letters on the
Yep, yep,
666.
yep. It's the number of the beast. It's a satanic math problem. All right. How we doing, Trey? So from -1 up to 5, how far am I going up? Yeah.
Ah,
Didn't trust it, huh?
66. 666.
Bailey.
That's not 66.
Word.
Yeah.
It's a calculator.
Go from there. I gotta get out of an awkward situation.
Yeah.
I gotta take this one, guys.
Sorry.
Think 5
Oh,
minus
Christ.
1. So 5 minus.
Hey, merge plane.
You did you took Miss Driscoll in math for 8th grade, right?
What's your highest plane?
11.
You had Miss Driscoll. Never had Miss Driscoll.
What's yours?
What's
What do
yours?
we do here?
16.
What's that?
Oh, I'm sorry.
Before?
I
11.
usually don't play games like
It's 17 now. Actually.
Can we have a VR
So-
game?
All right. We don't have a lot of time, so check my work.
Get busy.
Check my work. I might throw a curveball here to see if you're paying attention.
That game's like, yeah. The game. Yeah, this one. Where you?
I can tell Bailey's not paying attention right now. I don't even look for it.
Oh my God, John.
Yep.
There's something.
Is that right?
Yeah. No.
Sir.
What did I throw a curveball with?
6 and 12. It's 6, not 8. The difference.
Ah,
between
this right
6 and
here
12.
is off. Okay. That's supposed to be a 6. Okay. It's pretty ominous, isn't it? It's like from a horror movie or something. Okay, so 666 is my third difference. It's an Iron Maiden song. Anybody here listen to Iron Maiden?
I went to a concert last year
Did you? Did you go because your dad went, or did you go of your own accord?
on my own.
They're awesome. They're awesome. All right. All right.
Jeffrey was there too.
Who's that?
Jeffrey.
Jeff, you were at Iron Maiden? Number of the Beast, right?
We left on that song.
You left on Number of the Beast?
Just started playing it really
Oh, you guys disappoint me. Did you have to get to bed for school? Is that
I
what?
wanted to beat the traffic. It would have been bad. It would have been really bad.
All right. All right. I want to jump to here in case we get caught up here. Here's what I want you to do. Did anybody get this assignment from Mr. Erickson yesterday? Who had Mr. Erickson yesterday? Did he give this out to Jens?
No, he said do it in one.
Okay. Here's what I want. This is going to be due on Friday or on Monday. Monday. Okay, so you're going to have a few days to do this. I'm going to go off of memory because I don't have it written anywhere. So I reserve the right to change this sometime in the next hour. But we're going to do 1, 2, and 3. Do 1, 2, and 3. You can do those tonight, okay? I think there's another one that we do. I just can't remember which ones, but there's others that we do. But you can do 1, 2, and 3 tonight, okay? But before we do that, before we get funky, we are going to find the equation of the form. What form is this equation? What do we call the third one?
I forgot.
The first one is linear. The second one is Quadratic. The third one is cubic. Linear, we've dealt with linear equations for a long time now, right? So we should know what those are. Quadratic, that's kind of the funky one. What's another kind of makes more sense in our heads type name for it, would you think? What do we do to x in a quadratic equation? I heard it out there. We square, right? We square x. So sometimes you'll hear it referred to as a square function, but it's really called the quadratic, okay? Cubic, if you think about cubing something, what do? You times it by itself 3 times, right? So the quadratic, as far as names go, is the odd duck. But I want you to find the equation of the form ax cubed plus bx squared plus cx plus d that all ordered pairs above satisfy. What ordered pairs above? Is there something on the previous page?
Yeah, it's supposed to be those numbers, okay.
These numbers? Okay, so here's what it's saying. Find the equation that satisfies this chart. So what do you know? You know the third difference is 6, right? And what, according to, is it this table? No, it's not that table. It's this table. The third difference of a cubic is always what? 6 times what? The a. What is a? It's the number in front of my x cubed, right? It's the number in front of my x cubed. So if that number is 6, what must a be? 6 times 1 is 6, right? So a is 1. So now I know y, I know y equals 1x cubed. Now I gotta go back. What's the next pattern that I can figure out? What's the next pattern?
B.
6a plus 2b is this number right here. My second difference is 6a plus 2b. So let's go back to that. 6a plus 2b. Let's not go there. I want to go back here. 6a plus 2b equals 6. My second difference, 6a plus 2b equals 6. And I know a is 1, right? So 6 times 1 plus 2b equals 6. Does it?
Yeah.
What is this? Simplify this, Bailey. That's 6 plus 2b equals 6. How do I isolate the 2b?
Subtract 6.
Subtract 6. So I get 2b equals what?
0.
0. What does b equal?
0.
0. So I got plus, and we're going to write it in there just to keep track of it for now. When we come to our final answer, do I have to write 0x squared? Does it serve us any use to write that in as our final answer? No, but for now, we're just going to keep track of it so I don't have to ask myself, did I figure out what b was? We're just going to keep track of it that way. Now, what about my first difference? A plus B plus C is my first difference, right? Now, I know, I know my first difference is -1, right? So -1, I'm going to do this in blue over here. -1 equals A plus B plus C. And what did I say A was? A was 1. B is what? Plus 0 plus C. So what does C have to be? Well, let's do our algebra, right? How do I isolate the C? What do I have to do?
Subtract 1.
Subtract 1. Do you agree with that?
Common.
Yep, so subtract 1 from both sides. So -1 minus 1 gets me what, Sydney? Yes, I asked you first. -2, there you go. -2 equals C. So now I figured out my C. Minus 2x, right? Because C is the number in front of my x to the first power. Now I got to find out what D is, right? Now remember, when x is 0, the whole function is D. So let's go down here. When x is 0, my whole function's 2. So what is D?
2.
2. Plus 2. Okay? So I have just found the cubic polynomial that whole thing represents. So y equals, do I need to put the 1 in front of it?
No.
It's Department of Redundancy department stuff, right? So x cubed, do I need to put 0x squared?
No.
I'm just going to ditch that, right? Minus 2x plus 2. And if I plug that formula in and analyze it from 0 to 5, I should get all the same numbers that I got right. No, not there. There. Okay? So, problem set, due Monday. You're going to have at least numbers 1, 2, and 3. You're going to have some others, but stand by for those, okay? Thank you.